Hey guys, this is solutions to section 2.3 of the limit laws. And these problems are 3 and 4 under the example, evaluate each of the following limits. So let's start with number 3. And what I want you to notice is that when you plug 1 into this function, you end up with 0 in the numerator and 0 in the denominator. So when you plug 1 in here, you get 1 over 2 minus 1 over 2. And 1 minus 1. So that gives me 0 over 0. And that's an indeterminate form. And if you read the list of things to do when you have an indeterminate form above, when you have fractions, the best thing to do is try to find a common denominator. And so in example number 3, I'm going to make my common denominator 2 times x plus 1. And so my common denominator is going to be 2 times x plus 1. So what I'm going to do is I'm going to multiply every term of this expression by 2 times x plus 1. And then I'm going to simplify. So when I do this first term, the x plus 1's cancel from the numerator and denominator, and I'm left with 2. When I do this second term, the 2's cancel. So I'm left with x plus 1. And then the bottom, I'm just going to leave these all as they are. So x minus 1 times 2 times x plus 1. Okay, I'm going to keep simplifying. So I'm going to distribute that negative sign. And now I see in the numerator that I can write this as negative x plus 1 over x minus 1 times 2 times x plus 1. Negative x plus 1 is the same as negative 1 times x minus 1. And the reason that's important is because now I can see that this x minus 1 in the numerator and denominator can cancel out. So I have limit as x approaches 1 of negative 1 in the top and 2 times x plus 1 in the bottom. Now when I get to this one, I'm going to try to plug in 1 again, because remember 1 is the value I was going towards. So I'm going to try to plug in 1 again. When I plug 1 in here, I get negative 1 over 2 times 1 plus 1, or negative 1/4. So this limit of this original expression way up here is equivalent to negative 1/4. If you had graphed this, you probably could have guessed that that's what your limit was going to be. Or if you had picked some values near 1, like 1.01 and 0.99, then you would say, I guess the limit is going to be about negative 1/4. But to find it algebraically, that's what you need to do. Okay, so let's do something similar for number 4. And again, I'm going to pick a common denominator. In this case, my common denominator is going to be x times x minus 5. And I see that because this piece of the fraction has an x in it. This piece of the fraction has an x and an x minus 5. So the common denominator I need is that thing. So what I'm going to do is I'm going to try to make that first term in the expression have the same denominator. To do that, I need to multiply the numerator and denominator by x minus 5. So that gives me x minus 5 over x times x minus 5 plus 5 over x times x minus 5. Again, I'm only doing this because when you try to plug 0 in, you get 0 in the denominator, and that's bad. We don't want 0 in the denominator. Okay, so let's keep going. Now that they have the same denominator, I can combine them into a single fraction. And so that's going to be x minus 5 plus 5. And then we do limit as x goes to 0. The 5s are going to cancel because there's 1 in the top end, or there's minus 5 plus 5. So I have x over x times x minus 5. Now I have x in the numerator and x in the denominator, so I'm going to cancel that. So limit as x goes to 0 of 1 over x minus 5. Now that I've simplified, I'm going to try to plug in 0 again. So I get negative 1/5 as my limit.